Hello my students, your physics teacher Hassan Darwish with you. We continue the explanation of chapter 17 about the structure of the atom. In video 2, I explained Bohr's model of the atom. Remember, in his model, there are two primary postulates to interpret the discrete spectrum of the atom. In the first postulate, energy is quantized. That is, each atom has a set of allowed values of energy. In the second postulate, here it is, about the quantization of energy. In the second postulate was about the emission of light. He said an atom emits light only when it loses energy. That is, when the electron changes its position from a higher orbit to a lower orbit. And the energy of the emitted photon was, h nu equal initial energy level of the atom minus final energy level of the atom. In reality, Mr. Bohr worked intensively on the hydrogen atom, and he obtained the set of allowed values of energy of this atom in this rule. So the energy values of the hydrogen atom is given by this rule. Okay? Sorry. En equal minus 13.6 over n squared. But what is n? N is a whole number. Means 1, 2, 3, 4, etc. up to infinity. So if you look carefully at this equation, you see that En has specific values, not a continuous value, discrete values, due to its dependence on m, right? So the energy of this atom is quantized. Now this value of energy is given in electron volt. Means you have to change into joules if you want the energy in SI unit. Okay, this formula gives us the set of possible values of the energies of only the hydrogen atom. Now for n equal to 1, you get E1 minus 13.6. This is the lowest energy value. We call it what? Ground state. For n equal to 2, then you get the energy of the first excited state, or first excited energy level. N equal 3 minus 1.51 second excited level, and etc. Notice here, for n equal to infinity, replace here infinity, number over infinity squared equal to 0. Then the energy of the atom becomes 0, right? So this is called ionization state, or ionization energy level. Okay? But what does this mean? Means no more attraction between the electron and the proton of the atom. You know, H atom or hydrogen atom is the simplest atom. Consists only of one proton and one electron. That's why Mr. Bohr worked on this simple atom. So at the ionization state, the attraction between the proton and the electron is almost 0. And for energy bigger than E infinity, the electron and the proton are not bound together, means no more attraction. Clear? And the H atom becomes H ion. Notice also here, I want to emphasize on this. Look at the negative sign here. Clear? It means the energy of the atom, or the energy values, I mean, of the atom are negative. Means this is called bound system. Bound system because we have here in the atom proton, which is positive. Okay? And electron. Clear? Here is the electron. So there is attraction, okay, between them. This is called bound system. It means to separate from the electron from the proton, you have to do external work. Means you have to give the atom external energy. Okay, that's why the energy of the atom here is negative. This is called bound system. Okay. Let's go to a practical example. In this example, draw the energy level diagram of the hydrogen atom. It means you have the set of values, n equal 1, this energy, this energy, this energy. How do we represent a graph for this energy corresponding to n? Usually in atomic physics, we use this diagram. We call it energy level diagram. We draw as a vertical axis the energies, then we label n equal to 1 minus 13.6, n equal to minus 3.4, n equal 3 minus 1.51, n equal to 4 minus 0.85, n equal to 5 minus 0.544, etc. up to n equal infinity. Okay, notice here the space between two consecutive energy level is not constant. It decreases with time. It decreases with increasing n. Okay? The highest level is called ionization level. And n equal to 1 is called what? Ground state. Here is ground state. That's part A. In part B, calculate the wavelength of the photon emitted by the atom when it makes a transition from the fourth excited level to the first excited level. Means the atom will lose energy. Fourth means n equal to 5. First means n equal to 2. From this level to this level. So the atom loses energy. Means the electron changes its position from n equal to 5 to n equal 2. Then we have the emission of a photon. Clear? Say this is the photon. The atom releases what? Photon. We call it also gamma. Okay? Here is the photon. You know the rule. According to Bohr's second postulates, energy of the emitted photon is equal to the initial energy of the atom minus final energy, right? Here it is. Now we replace here initial energy is minus 0.54 plus, because minus times minus, plus 3.4, the final level. Here is the initial level minus 0.54, final level 3.4. If you do the calculation, you get 2.86 eV. Okay? Now we want what? The wavelength of the photon. You know the rule of the wavelength. E of the photon is equal hc over lambda or h nu, then lambda equal hc over energy للphoton. Now we replace the value of h, which is a universal constant, and the speed of light c, and this is the energy of the photon, 2.86 eV, electron volt. Change it into joules, and then you get the value approximately lambda approximately 4.37 times 10 to the power minus 7, or meter, of course, meter, which is 437 nanometer. Okay? Okay, that's enough for this video. Take care. Bye bye.